So welcome to the second tutorial, the second demo tutorial of HiVis. So in the first part, I showed you how to work with generally with the HiVis object. In this one, I will show you more of how to import annotations and classifiers from QPath. So this is a major part of HiVis. One of the largest strengths is using QPath in its all capabilities. Let's start. So as we created the object already in the last time, now the only thing that we need to do is just to load it. And the path is the pickle file we saved in the last tutorial. So now we want to start with a pixel classifier. So how to create it, I will have another tutorial in QPath, how to create it and how to export it. Basically, you just do a pixel classifier, then you load it into QPath, and you use the Groovy script, which is called export pixel classifier as label image. And then you will have a TIFF image, which will have this classifier. So in this case, I use this classifier which finds the muscle. So this is the thin gray area here. The tissue in brown, and in blue is the immune compartments, the immune follicles here. So all we need to do is to specify the name. So in our object, we will have now this muscle villi classifier inside the addata obs. And in this, we will import the pixels from the T file. So now all we need to do is to do our object dot add mask and specify those two. We can also plot or not plot it. And now I plotted it. It might take some time because we have a lot of spots, like 5 million. But anyway, we have now for each spot, it gets one value in this column of muscle villi classifier. So a spot here will only have the value 0 and so on. So now, because we have those numbers, we actually want to rename them to something useful that we can understand. And we can do it either by just accessing the HiVis object. I showed you before how to do it in the previous tutorial. You can also just do it in the undata inside it, or you can use the update meta, and then you need to specify the values. So in this case, for example, the lumen is 1 and so on. So we will have this dictionary, and we just can rename the values. So now if we plot it, the plotting will be covered in another tutorial, but this is just a basic plot of all the spots. So those are the 2x2 bins, the 2x2 spots, and they are colored by the muscle villi classifier, which we just imported. So we here we specify the colors and we make it transparent so we can see the image below. And as you can see, for example, the muscle here, we see that indeed the muscles cells are getting this muscle classification, which is nice. And this is the immune location. We see that all the immune cells are indeed blue. So this was Pixel Classifier, pretty easy, very useful. Now let's talk about annotations, which is also very useful. Annotations can be, tumor, non-tumor, just different locations in your data. Here I just did two annotations, one distal and one proximal. Of course, you can have multiple proximal, multiple distal, and so on. So you don't have to have only one annotation per category. So when we do the annotation in QPath, we just click on File, Export as GeoJSON after we select the annotation that we are interested in. And now we will have this GeoJSON file. So in this case, we will call it the intestine part. So this is either proximal or distal. And all we do is add annotations, specify the path and the name, and we will have this mask inside. So now if we plot it, so in this plot, again, all the bins, all the small 2x2 bins are colored by this annotation name. In this case, it's the intestine part. And we see that all the spots here and here are distinguishable. Now, this is one thing that we get. Another thing that we get is in case we have multiple annotations of the same class. For example, if we would have two different distal annotations or two tumors or individual villi and so on. So all the beans will get, in this case, the distal annotation, but we will also have the same name with ID. So we will have the intestine part and also the intestine part ID. So in this case, they are the same because we only have one annotation per class, but we can have multiple. And then for each bean, so we have here 5 different beans, 3 of them are distal, and those 3 are in this case in the same annotation, but they can be in another one with also distal class. So yes, now another thing which is useful mainly for plotting, but also if you want to do analysis on the structures themselves and not on the spots, and this is to aggregate them. So we will take all the spots inside those aggregations, or again, this could be single cells, this could be everything, anything, and we can aggregate them together. So sum the expression in them up and also aggregate some of the metadata inside the spots. So in order to use it from annotations, we use this function aggregate from annotations. We can also have aggregate from cells, which we will cover in another tutorial. In this case, it's very easy. So we do aggregate from annotation. We specify which column we use. So in this case, we use the ID intestine part. So it can have multiple yellow ones, for example. And we call it a name. This name, we will be able to access it later by using si.aggregations. So this is a dictionary. And inside it, we will have this intestine part, which we are creating now. So if you will go to the tutorial that I did with the general workflow, I told you that we can work on beans, but we can also work on structures or cells. So this is how we create those from annotations. And also we can specify the GeoJSON path. In this case, because it's annotations, it's the same GeoJSON we used here. And we can also aggregate some OMS. We will skip it for now. You can check the documentation. But anyway, if we now plot it, we can plot now cells. So we don't plot si.plot. We now use the si.ag and call this aggregation, in this case intestine part, and then we do plot, and then we can do spatial, histogram, or cells. When we do cells, we will actually have the outline, which we control the color and everything. So this is very pretty and useful. So as before, we just save the object for the next tutorial.